Okay, more general trigonometric functions and models. We're going to go over all four of these characteristics: mathematical modeling, of course, with your word problems, and it's pretty much transformations of sine and cosine. All right, so the first problem says find the zeros and the turning points of each function on the interval of 0 to 2 pi. So here's the graph, our original graph, and I'm going to do A in red. So if we look at, well, hold on, let's actually do our parent function. Our parent function is y equals sine x, and if you remember, sine at 0 is 0, at pi over 2 it's 1, pi at 0, 3 pi over 2 it's negative 1, and 2 pi. So our sine goes something like this. Alright, so let's actually do A in blue. So since it's 1/2, the 1/2 tells you to take your graph down a half. So instead of being at 1, it's going to be at a half. Instead of negative 1, it's going to be at a half. So the y equals 1/2 sine x looks like this. And let's see, let's pick another color for, let's pick green, and we'll do green for B. B, because there's two things we got to worry about here. First, it's a 2, and the other is that it's negative. The 2 is going to increase your graph by 2. So normally it would be up here at 2, but because it's negative, it goes down here. So now here it would be at 2, but it's negative, so it's going to do the opposite. So our green one is going to go something like this. What I want you to see is the negative flips it, and then the number itself, it tells you what's your, and it's called amplitude. Let me go ahead and do the turning points as well. So let's go to our red. Okay, so red is for this one here. The turning points here is right here when it's going from positive to negative. So this turning point would be at x is pi over 2, y is 1, and then this turning point would be x is 3 pi over 2, y is negative 1. For the green, which is going to be our B, our turning points are going to be the same thing, except for this turning point is going to be pi over 2 and negative 2. And this turning point is 3 pi over 2 and 2. Okay, this is your problems. What I'd like you to do, maybe just pause this, go ahead and try these problems. I'm going to put the answers up for you. Okay, here's the answers for problem 1. TP stands for turning point. Alright, this is the formulas for amplitude and period. And that's all you have to plug in. And just remember that with B, remember that whenever you have something that's actually with X on the inside, it's the opposite of what you think it would be. The A, the amplitude, tells you how tall your graph is going to be. And the B is what tells you about your horizontal switch. It switches around your period. Alright, find the period of each function. So we just have to use that formula that we had before. Okay, so our period is 2 pi over B. So for A, our B is 2, so we'd have 2 pi over 2. Therefore, the period is pi. Alright, let's do B. 2 pi over what our B is. Now think about this. X over 2 is the same as 1/2 times X. So our B is 1/2. If we go 2 pi divided by 1/2, which is 2 pi times 2 over 1, therefore your period is 4 pi. Alright, again, here's some problems for you to do. Go ahead and pause and I'll put the answers on there for you. Okay, there's your answers. Alright, moving right along, I've got two graphs here, and these graphs are of this. I think what I'm going to do is just use this bottom graph, so let me get rid of this other graph. Well, we'll just shrink it down. Oops. going to use that one. Let's just put it over here. All right, so let's take a look at this graph here. It says that we want to go from -4 to 4, and we want to graph the cosine of pi x over 2. So we have to find the amplitude. The amplitude is how tall it gets, so we know that A is equal to 3, because remember, amplitude is the absolute value. That gives us A. Our turning points aren't so hard because we can see that it turns here, 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 and here. So let me move my graph over a little bit. All right, so my turning points, and again, remember that they're points, so you can't just put -4. You need to go negative, or actually, yep, it's -4 to -3. That's this one here. And then the next one would be -2 to 3. And the next one is 0, -3. And then we have 2, 3. And the last one is 4, -3. As for the period, all we have to do is, let's shrink this down so I can get some more room. Okay, so for the period, we're going to go 2 pi over b, and our b is going to be pi over 2, so 2 pi over 2, which is going to be 2 pi divided by pi over 2. So 2 pi over 1 times 2 over pi. Cancel out your pi's and you get 4. Okay, now this next slide, this is the, let's extend it. This is the graph, and I'm going to give you the answer. So go ahead and pause and jump back on when you're ready for the answer. Okay, there's the answers. Let's move on. Graphing with having all of your characteristics here. Okay, if you think about a phase shift is like a horizontal shift, but they don't call it that. In Trig, they call it just simply phase shift. Remember when we had something like x minus 2 squared, and we wanted to find out how much to shift it? We would do x minus 2 equals 0, so x equals 2, so you do the opposite of what it is. You do the same thing for the phase shift. Take bx plus c equals 0 and solve for it. X. So bx equals -c, therefore x equals -cb, and that'll tell you what your phase shift is. All right, so going on to this next problem, we've got y equals 1/2 cosine 4x minus pi, and they're going to want us to sketch this. So the first thing I'm going to do is I'm going to find the amplitude, and the amplitude is simple, it's 1/2. I need to find the period, so to find the period we go 2 pi over b, and b is 4, so 2 pi over 4. And so we've got the period is equal to pi over 2. All right, let me make some space here. Let's erase this and put just pi over 2. Okay, pi over 2. And then our phase shift is -c. Well, actually, we're just going to solve for that. 4x minus pi equals 0. So 4x equals pi. So x equals pi over 4. That's our phase shift. All right, now to graph it, if you, okay, so if we graph like this, we're going from -pi to pi. So this is going to be pi over 2, and this is -pi over 2. Let's do our parent function first. If we just did cosine, the cosine at 0 is 1. And here it's 0, and here it's -1, so this is 0, and this is -1. So it's going to go something like that, our parent. Now, if we start putting everything else in, we know that our period is pi over 2, and our amplitude is 1/2. So let's do our period and amplitude together. If our period is pi over 2, that means that everything is going to repeat in pi over 2, and it's only, oops, wait, this should be down here at 1/2. Hold on, let's erase this. This should be down at 1/2. Okay, so down here at 1/2 and down here at 1/2, halfway in between, or like this, halfway in between is where it's going to be its maximum, so it's going to be something like this. That gives us our amplitude and our period, and then the only other thing we have to do is we have to move it over. So let's get a different color. Let's do blue. And then for blue, we need to shift it by pi over 4. So we need to shift it this much. So that means that this point is now here. This point we're going to put over here. This one we're going to put over here. And then this one is going to go here and here. So what we're doing, it's like we're peeling it, lifting it up and moving it pi over 4. Okay, if you notice, you have an amplitude of 3/4. Pi is your period and a phase shift of negative pi over 2. The red is our original one. The green is where I did it with a, I guess I should extend that out to do it like this. Notice it goes to 3/4. Oops, it should go up a little bit. It should go to 3/4. And to negative 3/4. And then what you have to do is you've got negative pi over 2. Negative pi over 2 is going to flip it and shift it over. All right, number 12, all this is just telling you that the only things that I really want you to have are, I will show you, I want you to know that sine and cosine, and go ahead and add secant and cosecant because they all have the same characteristics. That's going to be this here, your amplitude, your period, and your phase shift. Notice that the period goes with 2 pi because sine, cosine, secant, and cosecant's period are 2 pi. And then on this next one, I want you to notice is with tangent, the only difference is that your period is pi instead of 2 pi because that's the tangent's period. Okay, so our next one here, we've got the graph of y1 equals 3 sine x plus 4 cosine x. We want to use, and let me go ahead and stretch this out so we can see what we've got. We want to use this graph to find out what would be another equation so that we just have one trig function. First thing we need to do, let's find our amplitude. And our amplitude is 1, 2, 3, 4 is 5. And then we need to also find out what our period is. This point right here is negative 0.927. I'm just going to tell you that. And then it starts to repeat itself here, so let's find that point. Okay, and then this point right here is 5.355. Don't use the negative. Let's just find out what the distance is. It's something about 6.28, which is actually 2 pi. So our period is 2 pi. From that, we can find out what b is. Remember, period is 2 pi over b, and we know that our period equals 2 pi, so therefore b equals 1. Now that we know what our b is, we can figure out what our c is. Because if you remember that our phase shift is negative c over b, and this point right here tells us what our phase shift is, and it was negative 0.927. Always go the closest to 0 as you can. So, and then remember our b, so let's erase b and put that b is equal to 1. So we've got that c equals 0.927. We have a, b, and c. From here, let me scoot this down so I have some room. All right, from here we can say that y equals a, which is 5, sine, and then b is 1, so 1x, but we don't have to put that. And then our c was equal to 927. If you plug that into the calculator, plug this into Y2 and plug in Y1, they will be right on top of each other. All right, it's your turn. Go ahead and pause and start again when you're ready to find out the answer. Okay, there's your answer. Again, just doing it just like I did the last one. Okay, cruising right along. Temperature variation. All you're doing now, unfortunately, again, they gave you the equation. You could figure it out yourself. This is your X. This would be, or this is your L1, and this would be your L2, and you would be looking for the sine regression, and it would give you this formula. So this one, if it says I'm looking for April 1st, and X1 is January 15th, so that's January 15th, February 15th, March 15th, so 4 is April 15th, but we need the first, so we would say X is equal to, if you think in between there, 3.5. Plug and chug, and you should get an answer of 33.5 degrees. And all that is the average high temperature in Fairbanks, Alaska. So if you went through and did this next problem yourself, again, just plugging and chugging, you should get 8.5 degrees Fahrenheit. All right, there's your homework, and I'm done.